Hello there, children. Today we are going to work on some section 5.4 and 5.5 review. So let us begin. So first, this was a selected group of problems that you yourselves asked for. So ask and ye shall receive, within reason, of course. So this first problem looks particularly nasty until I figure out that, hey, they look like they're sums over there. And when they are sums, I can use my sum and difference formulas. So the cosine of pi over 4 minus x, that is a difference formula there, and within that difference formula I can go ahead and substitute in the difference formula for cosine. Now that would be alpha right there, and that would be beta. Filling that out would be the cosine of pi over 4 times the cosine of x, that's it right here, and that would be plus the sine of pi over 4 times the sine of x. We are then going to subtract from that whole thing my other item there, which is this. Now then, that is the difference formula for sine. So when I go ahead and work on through that, remember the subtraction sign in the middle, and I look on my handy-dandy formula sheet, which you were all provided, and I get the sine of pi over 4 times cosine of x minus cosine of pi over 4 times sine of x. Now, when I drop the negative sign into here, that's going to be something magical. Now, as you know, pi over 4 is a value on my unit circle. The cosine and sine value are root 2 over 2. Now, how is this helpful to me? Well, looky here. As you can plainly see, things are going to cancel. Oh, happy days are here again. So when I look at this, this becomes root 2 over 2 sine of x. Now look in the middle here. This and this item are the same but opposite signs. They are going to cancel out. Ooh, now that pleases me greatly, because this whole thing is still going to be equal to 1. It's going to be negative 1. Now I have root 2 over 2 plus root 2 over 2. That means there are 2 root 2 over 2's, or just root 2. You have half of a root 2 and another half of a root 2. You get a whole root 2. Sine of x equals negative 1. I'm going to divide both sides by that square root of 2. Which leaves me this. Hey, this isn't on my unit circle at all, but don't you worry about that, because that we're going to rationalize. Oh, happy days are here again, leaving me with sine of x equals negative root 2 over 2. Now, where does that happen? Well, lucky for you, if you memorize that unit circle like you are, I know, eager and waiting to tell me that you did. That is 5 pi over 4 and 7 pi over 4. Because I need the y value to be negative, because that's sine. Moving on to bigger and... Now this next problem, pardon me for taking some liberties here already, but I'm not a fan of radians. Sorry. Problem 6. No, sir. I know that you are that, but I am going to simply convert it to degrees. Now, why would I convert it to degrees? Because I can quickly and efficiently add that up as 315 and 30. Now, why would I do 315 and 30, you might ask? Excellent question. I pick 315 because that is one of my wonderful values of tangent, just like 45 or 135 or 225. Then I take the tangent of that, gets me 1 or negative 1. So then I use my formula. That is the sum formula for tangent, which you have, again, on your formula sheet. Now let's get cracking here. The tangent of 315, you don't even need a cheetalator for that one. It's -1. The tangent of 30 is root 3 over 3, because that's y divided by x. This becomes 1 minus -1 times that root 3 over 3, which becomes this. Now, this is not an acceptable answer, as you've probably figured out by now. So, what in the world do I do? Well, I've got to rationalize this. Now, when I rationalize this, and people are asking, why rationalize? Because I've got to square it in my denominator. I multiply top and bottom because sharing is caring. Thank you, imaginary voice. I only worry about the denominator. That's what I'm concerned with here. So what I do with that denominator is I am going to do the following. I'm going, hey, denominator, what do you need to get multiplied by so that I don't have the ugly awfulness of a square root? And I always take that middle sign and switch it. And now I go ahead and do some FOIL action on the top and bottom. Now, when you FOIL the bottom portion here, you get the following. 2/3. Okay, while it's a fraction, doesn't contain a square root. Oh, great success. Let's FOIL the top part. Oh, top part, why are you such a pain to FOIL? It's okay that you are. We still appreciate you. But it's just going to give me this. Now, I can't leave it like that. Sorry, that's a little awful. So instead of dividing by something, I'm going to multiply by the reciprocal being 3/2. Now, when you do this, that's going to require you again to do a little distribution action. And when you end up getting that, when you distribute the -3/2 in there, you get a -2 plus a root 3. Or you could rewrite it if you so felt the need as root 3 minus 2. Oh, happy days are here again. Great success. Let's move on. On to the next problem here, which is again one of those fancy ones that looks really awful until I have the earth-shattering revelation that, wait a minute, wait, I see you there, sneaky problem. You're just a sum and difference formula in disguise. Tricky, tricky problem. So, I go ahead and look at my sum and difference formulas. Now, the thing I gotta remember is unlike the last problem where they were both one formula, this is not that particular formula. One is a sum formula and one is a difference formula. So the key trick for me is do not simply just go ahead and write down one or the other, because you will end up making a mistake. Be careful of which one you write down. So the first one's a sum. I look at my sum formula. All right, that's cosine of 5 pi over 4 times the cosine of x. And then I do minus, because it's a sum formula for cosine, sine of 5 pi over 4 times, well, let's see, the sine of x. Now I go look at the other formula. Now the other formula dictates to me that I am in fact going to have a difference, so that is this. Now luckily it's a plus sign in the middle here, up in front, so I don't have to worry about distributing a negative, so I can just go ahead, henceforth, and just drop some serious knowledge on this problem. Now, it's very important, like I said again, when you're dropping said serious knowledge, this, if you think, oh, they're both additions, no, they're not. This should be a subtraction symbol here. So I know a lot of people wanted to put that as an addition. That's a common mistake people make because they think, oh, every problem is just plus plus when they do this. It's not. So you have to be really careful of your formulas here, because otherwise you end up making mistakes, which would be not good for the overall grand scheme of the problem. S equals 0. Now we go to our unit circle and figure some stuff out. I'm going to go from right to left here because I'm standing over here. Cosine of pi over 4, that makes negative negative, it's positive. Now, when I do this, I end up getting the following. as I go through here and realize, hey, look, everything's negative root 2 over 2, because that's pi over 4 in the wonderful quadrant I'm in, I see this wonderful, glorious result here. Now, the key important point is, let's look. I've got a negative root 2 over 2 cosine of x. There's a negative root 2 over 2 cosine of x. That gets me a negative. I'll do it in a color so you can see that a little bit easier. These two combine together to make a negative root 2 cosine of x. These two add together to make a wonderful and glorious root 2 sine of x. That's going to equal 0. Well, I'm just going to divide everything by root 2. I'm allowed to do that and just cancel them out. I'm left with negative cosine of x plus sine of x equals 0. I'm going to add a cosine of x to both sides and just see what I'm looking at here. I have one trig function equaling another trig function. So the question I have is, where in the world does sine of x equal cosine of x? That only happens at two spots, folks. When x is pi over 4, because both my coordinates are root 2 over 2, and x is negative 5 pi over 4, as you've seen in this previous example here, but it's going to be positive 5 pi over 4, because they're both negative root 2 over 2. Done deal. Moving on. Now, this next problem is quite interesting. 2 cosine squared of theta divided by 2 minus 3 cosine theta equals 0. Theta divided by 2, that's half an angle. Hey, wait a minute. Wait, oh, look at that. There are these half-angle formulas on my formula sheet. Forgive me if I'm just going to drop one of those in there right now. That is a half-angle formula for cosine. Now, it's squared, right? Now, I know this looks awful, but I'm squaring it, which means I'm not only going to kill off my square root in there, which is phenomenal, I'm also going to kill off the plus minus. How, you might ask? Because when I have a plus minus, guess what happens? If I square a positive, I'm getting a positive. When I square a negative, I'm still going to get a positive. So that problem, which looked atrocious as I worked through it, now, you're not so bad. You're not so bad at all. It starts really awful, but breaks down really easy. And what I can do from there, since I'm going to have it set equal to 0 already, which is phenomenal, cosine theta minus 3 cosine theta, that's a 2 cosine theta, plus a negative if you like. Since I made a plus sign, might as well use it. You could have minus there, I just wrote a plus sign and didn't feel like erasing it. Now I'm going to subtract 1. Give me negative 2 cosine theta equals negative 1/2, because I will be dividing by negative 2. Now, when you have a negative divided by a negative, that's going to get you a positive. Now, you look on your unit circle, and you're like, all right, where the heck does cosine of theta equal 1/2? There's only two spots that happens. Theta equaling pi over 3, and theta equaling 5 pi over 3. Quadrants 1 and 4 my unit circle. All right. Done deal. Moving on. Now the next problem here, I'll give you a second to read this. Now, as you read it, sound waves can be modeled by the equations of the form y sub 1 equals 20 sine 3x plus theta. A wave traveling in the opposite direction can be modeled by y sub 2 equals 20 sine 3x minus theta. So that this is true. Okay, well, guess what? When I end up doing that, if I write it all out here, y1 is this. Alrighty. And y2 is this. Alright, guess what I'm going to have? I'm going to yank out that 20 for a little bit here until I can deal with it later. I just put two parentheses there just to show you what's happening. So let's begin the work. Now that 20 sits out in front here of this particular problem. And I will split it up in terms of doing it in red here. Now this is an addition or sum formula. So we go ahead, sine 3x cosine theta. And then plus cosine 3x sine theta. Now what I do with the other portion is, remember, you got to distribute the 20 to both of these as well. Don't forget to do that. So I'm going to put it in parentheses like this for a second. And that's 3x minus theta. That's the difference formula, folks. Don't forget about that. And when I write it all out here, I end up getting this. Now this is based on your formulas, and reminder that in these particular cases, your alpha values are 3x and your beta values are thetas. Now I distribute the 20 in here, and this is a lot of writing. But it's okay, we'll all manage. So we go ahead and write this out and continue working. Now as you do this, you know what the end product should be because they told you what they wanted. So the trick here is seeing if something maybe will magically cancel. Because luckily you know the end result. So you're looking maybe, just maybe, will something go away? Now, luckily something will go away. I was hoping, upon hope, that these two would go away. They did not. So that's unfortunate. But I look. 20 cosine 3x sine theta. Do I have any of those? It's negative. Do I have any? Ooh, look at you right there. You're the same. Goodbye, you go. Now, I look, and this thing in purple here and this item in purple are the same. So 20 plus 20 is a wonderful 40. And it's sine of 3x. And that attached cosine of theta, which, lo and behold, is what they wanted in the problem. You are now ready to tackle the assessment. Go henceforth and do. Proceed.